Let's rethink how we grow our own food. Most people picture neat rows of plants in a patch of dirt, measuring success by square feet. But focusing only on ground space is a trap, especially if you're serious about feeding yourself. Not everyone has acres to spare. Maybe you just have a balcony or a small backyard. If you only look at the ground, you're missing out on all the space above your head. It's a two-dimensional solution for a three-dimensional problem. The real world is tough, and resources, space, water, time are limited. Spreading out across the ground is inefficient and labor-intensive. If you want true self-sufficiency, you need to think less like a farmer and more like an engineer. The question isn't, how much land do I have, but how much volume can I use? The future of food production, especially in tight spaces, is about building upward. Maximize every cubic inch you control. This isn't just a clever trick, it's a necessary evolution in how we feed ourselves. Stop looking down, start looking up. Let's talk about protein, the building block of life. Most people think of beans as the go-to garden protein. On paper, it sounds good: plant, water, harvest, eat. But the math doesn't add up. Growing enough beans for real protein takes a huge amount of space and effort. You'll spend months tending rows, fighting pests, and end up with a small harvest. To meet one person's yearly protein needs, you'd need a field the size of a parking lot. That's a lot of work for a little payoff. Every pound of beans costs you dozens of square feet and months of labor. It's inefficient. A hobbyist's approach to a survivalist problem. If you want real self-sufficiency, you can't afford this kind of inefficiency. Relying on traditional crops for protein is a losing game. We need a way to produce massive protein in a tiny space, with less work. It sounds impossible, but it's not. The answer isn't in the garden. If open fields aren't the answer, what is? Think closed containers, not soil and rows. Create a controlled environment, a box, tank, or barrel. You become a system operator, not just a gardener. In a container, you control water, nutrients, and light. Perfect conditions, year-round. No weeds, no pests, no drought, just non-stop growth. Your garden becomes a compact vertical unit, on a balcony, in a garage, even a closet. You're limited only by your ingenuity, not your square footage. Every drop of water and nutrient goes straight to the plant. Nothing wasted. It's a closed-loop system, far more efficient than dirt. This isn't science fiction. People are doing it now. You'll use pumps and air stones instead of shovels. Build the perfect world for your crop, and you'll get harvests you never dreamed of. This is modern food production, one container at a time. The future is vertical, efficient, and engineered. Once you embrace containers, new possibilities open up. Enter aquatic plants, specifically duckweed. That green scum on ponds? It's actually a protein powerhouse. Some duckweed species are up to 45% protein, higher than soybeans, and it grows incredibly fast, doubling in mass every day or two. No traditional crop can match that speed. With duckweed, you're harvesting daily, not seasonally. Scoop some out, and it regrows by tomorrow. It's continuous, reliable production. A living protein factory. Duckweed floats on water, perfect for stacked vertical systems. Multiple layers mean multiplied yield, no extra floor space. Forget weeding and tilling, manage a liquid ecosystem instead. Just provide water, light, and nutrients, and duckweed does the rest. It's a simple, elegant solution for high-efficiency, small-footprint protein. This is next-level food production. Give duckweed the respect it deserves. Ready to build? Here's how to make a protein bioreactor from hardware store materials. Start with a large black plastic trash can. Blocks outside light, keeps you in control. Aeration is critical. Use a strong aquarium air pump and large air stones at the bottom. Bubbling water keeps nutrients moving and prevents stagnation. Add simple plastic baffles inside to direct water flow and eliminate dead spots. Cut baffles from plastic sheets and silicone them to the can's walls. This turns your trash can into a high-performance reactor. Mount a full-spectrum LED grow light above the can, on a timer for 14 to 16 hours a day. Artificial light means you're not dependent on the sun. Run it anywhere, anytime. What you've built is a machine, a self-contained, optimized protein factory. It's not pretty, but it's brutally effective. No garden plot required, just smart engineering. This is food production for the modern age. Build one, and you're on your way to real self-sufficiency. The future is in your hands. A high-performance system needs high-performance fuel. You can't just use tap water. Nutrient balance is vital. Don't worry, you don't need a chemistry degree. Duckweed needs nitrogen, phosphorus, potassium, and a few minerals. Nitrogen is key for protein. Use a high-nitrogen fertilizer or a hydroponic mix. Phosphorus and potassium support growth and health. Commercial hydroponic mixes have everything balanced. Just follow the instructions. Micronutrients like iron, magnesium, and calcium matter too. Monitor your system. Yellowing means low nitrogen, slow growth means adjust nutrients or change water. It's about observation and small tweaks, not daily backbreaking labor. Spend a few minutes each week checking levels and harvesting. You're not just a gardener, you're a life support tech for your food. This control is what makes the system so productive. Feed the system, and the system feeds you. It's a simple, powerful loop. Let's bring it all together. Traditional gardens are flat and inefficient for protein. Beans and ground crops are too much work for too little food. The solution? Think in cubic feet, not square feet. Stack your bioreactors vertically. Multiply your output, not your footprint. Turn a balcony into a food factory. This isn't just a gardening hack. It's a mindset shift. You're managing a purpose-built system, controlling every input for reliable results. It's the difference between hoping for a harvest and engineering one. This is real food independence for anyone, anywhere. Use your brain, not just your back. Vertical, efficient systems mean protein for your family, no matter your land. The future of food is smart, compact, and vertical. Stop digging, start stacking. Your survival could depend on it. You built a bioreactor, filled it with duckweed, and waited for a lush green harvest. But nothing's happening. Your plants look sad, maybe yellow. You've checked nutrients and temperature, but you're missing the real engine light. Not just any light, but the right kind. Powerful, targeted, and intense. Most people skimp on lighting, thinking any bulb will do. But for duckweed, light is food. Without enough of the right kind, your system stalls. In nature, sunlight is intense and full spectrum. Your job is to replicate that power efficiently. Just hanging a shop light over your tank won't cut it. Lighting is the difference between a thriving bioreactor and a stagnant pond. It's not just about brightness, it's about spectrum, placement, and penetration. If you want real growth, you need to treat lighting as your top priority. Forgetting this is the #1 reason bioreactors fail. Let's fix your lighting and unlock your tank's true potential. Let's talk about PAR, photosynthetically active radiation. Plants only use certain wavelengths for photosynthesis, mainly in the blue and red spectrum. Household LEDs look bright to us, but they're mostly useless for plants. In a deep tank, light fades fast. Top layers hog it, bottom layers starve. That lush surface mat, it's blocking light, creating a dead zone below. Without proper penetration, your system becomes a compost pile, not a farm. You need high PAR grow lights, not office bulbs. And you need a way to get that light deep into the tank, not just on top. Hanging a bright light overhead only feeds the top millimeter. The rest of your tank is wasted space. The solution? Deliver the right light to every plant, top to bottom. That's how you turn a bioreactor into a real protein factory. Plants crave specific light, mainly blue, 450 nm, and red, 660 nm. Standard white bulbs waste energy on green and yellow, which duckweed reflects, not absorbs. That's why your tank glows but doesn't grow. Horticultural grow lights focus on those red and blue peaks, maximizing photosynthesis. They look strange, purplish or pinkish, but to duckweed, it's a feast. Nearly every watt goes into growth, not wasted light. Ignore lumens and wattage for humans. Look for full spectrum or red-blue output. These lights cost more, but the payoff is explosive growth and efficiency. Give duckweed the spectrum it evolved to use, not a junk food diet. Work smarter. Feed your plants the light they crave. Top-down lighting leaves most of your tank in the dark. The fix? Bring the light inside the water column. Use waterproof, high-intensity LED strips sealed in clear tubes. Your lightsabers. Mount these vertical columns throughout the tank. Now, every plant is just inches from powerful targeted light. Building these is simple. LED strips, clear tubes, end caps, and aquarium-safe sealant. Suspend the columns, connect to power, and you've got a pro-grade system. No more top versus bottom layers, just a single productive growing zone. Even light means no self-shading, no wasted space. You're farming the entire volume, not just the surface. This is how you unlock three-dimensional productivity. With vertical lights, your bioreactor becomes a high-intensity production machine. Duckweed grows everywhere, not just on top. Circulation keeps plants moving, exposing all to light. Under ideal conditions, you can double your biomass every 24 or 48 hours. That's exponential growth. 1 pound today, 2 tomorrow, 4 the next. Protein content can hit 45% dry weight, rivaling soybeans. You're producing protein at home, faster than any field crop. Vertical lighting multiplies your output by using the whole tank, not just the surface. Yield is now measured by cubic feet, not square feet. Every inch of water is productive. The system is efficient, controlled, and focused on one goal: protein. This is the power of a well-lit, well-designed bioreactor. Exponential growth means you must harvest daily. If you don't, the tank chokes, plants die, and the system crashes. Overcrowding blocks even vertical light, leading to rot and toxic buildup. Harvesting half the biomass each day keeps the system healthy and productive. It's not optional, it's the secret to continuous success. Use a fine mesh net to scoop out half the duckweed. Circulation ensures you get a good mix from anywhere in the tank. The process takes minutes but makes all the difference. Regular harvests prevent crashes and keep protein flowing. The daily harvest is your reward, the whole point of the operation. Skip it, and your green gold mine turns into a disaster. Stay on schedule, and you'll have a steady, reliable protein source. That's how you keep your bioreactor booming. Fresh duckweed is 95% water and spoils fast. To make it useful, press out as much water as possible. Use a potato ricer or small screw press, squeeze, collect the liquid, and return it to the tank. You'll get a dense green cake. Now dry it. Use a food dehydrator or a low oven to get moisture below 10%. Dry, crispy duckweed stores safely and won't mold. Grind it into a fine powder. This is your protein-rich feed. Mix it into animal rations or store for later. You've turned pond slime into a valuable, shelf-stable product. The process is simple. Harvest, press, dry, grind. You control every step, from light to final product. That's how you turn a dirty job into a sustainable business. Your green gold mine is now a real protein factory. Many dream of self-sufficiency, growing food, raising chickens, maybe running a small bioreactor in the garage. The appeal is obvious: control over your food, a sense of accomplishment, and the hope of weathering tough times. These small projects are great for learning, and they offer a taste of what's possible, but they're not a survival plan, and they won't sustain you when it matters most. A few pots of tomatoes or a single protein reactor is a hobby, not independence. They're stepping stones, not the destination. Relying on tiny systems is a dangerous illusion. They'll never free you from the grocery store. When shelves go empty, you'll realize how little these setups provide. True independence requires a shift in mindset. You must think bigger, plan for more, and design for real needs. Survival is a numbers game: calories, protein, nutrients, every single day, for every member of your household. It's about meeting real dietary needs, not just supplementing them. That small bioreactor? It's a proof of concept, not a solution for winter or crisis. When the growing season ends, you'll need more than a science experiment. You can't feed a family or livestock with a science fair project. Real food security means abundance, not scarcity. Many stop after their first harvest, mistaking a supplement for a staple. But a handful of produce isn't a meal plan. Real self-reliance means replacing store-bought meals, not just adding a garnish. It's about producing the bulk of what you eat, day in and day out. You must move from gardener to engineer, building systems that produce abundance, not just survival. This is where the real challenge and the real reward begins. The single bucket is your training ground, not your destination. Use it to learn, experiment, and prepare for what's next. Learn the basics, then scale up. Every skill you master now pays off when you build bigger. Real freedom comes from applying those lessons to a system that's orders of magnitude larger. That's when you start to see true results. Move beyond the scale of a hobby and into serious, reliable food production. This is how you build resilience. The journey to self-sufficiency is about scale. It's about building systems that can truly support you, season after season. Build a machine that works for you, producing the core resources you need to be truly independent, and finally break free from the limits of small thinking. Protein and calories are your foundation. A single 50-gallon bioreactor might supplement one person, but what about your family, your animals? Most people underestimate their needs and forget about the buffer for winter or the unexpected. True independence means producing a surplus, enough for you, your animals, and emergencies. A system that only meets your daily needs is one bad day from failure. Scaling up isn't about greed, it's about resilience. To replace store-bought protein, you need to harvest kilograms, not grams. Managing dozens of tiny systems is inefficient and exhausting. Homesteading should create freedom, not more work. The only logical path is to consolidate and scale up. Your protein reactor should be the heart of your homestead's biological engine. Anything less is just playing at self-sufficiency. When you need more output, don't just multiply small systems. It might seem logical to add more tanks or reactors, but this approach quickly becomes overwhelming. 10 small reactors mean 10 times the work, 10 times the failure points, and 10 times the maintenance headaches. Multiplying small systems leads to inefficiency and chaos, filling your workspace with clutter and making troubleshooting a nightmare. A single large tank is far more efficient. One pump, one heater, one set of controls. Everything is streamlined and easier to monitor. You save energy, materials, and time. Fewer resources are wasted, and your workflow becomes much smoother. Large tanks retain heat and light better, making them more productive and stable for your protein cultures. Managing one system is simpler and more robust than juggling many. You can focus on optimizing a single environment. Complexity is the enemy of resilience. The more complicated your setup, the more likely something will go wrong. Fewer moving parts mean fewer things can break, and repairs are faster and less expensive. The leap to true production is about consolidation, not multiplication. Scaling up means thinking bigger, not just adding more. Think about building a proper vessel, an intermediate bulk container, a livestock trough, or a custom tank designed for your needs. Create a single, controllable environment for your protein culture, where every variable is easier to manage. This is your most important engineering decision. The right tank design will save you countless hours and resources. It sets the foundation for abundance, efficiency, and long-term success in your operation. A large tank needs more than just water. To truly function as a reactor, it must become a carefully engineered environment, designed for both efficiency and reliability. 4 pillars make it work: hydraulic flow, aeration, lighting, and automated nutrients. Each one is essential, and together they create the foundation for a thriving system. For flow, a strong pump creates a gentle current, keeping the culture suspended and healthy. This circulation prevents stagnation and ensures nutrients are evenly distributed. Aeration is critical. Use a reliable air compressor and diffusers to deliver oxygen or CO2 throughout the tank. Proper gas exchange supports rapid growth and prevents dead zones. Lighting matters, especially for photosynthetic cultures. The right spectrum and intensity can dramatically boost productivity. Surface lights won't reach deep enough. Use submersible LED strips to illuminate the entire tank. This ensures every layer receives the energy it needs. Automated nutrient delivery is essential. Consistent dosing keeps your culture growing at peak rates. Manual feeding is impractical at scale. Use a peristaltic pump and timer for precise, consistent feeding. Automation reduces errors and saves labor. These upgrades turn your tank into a high-performance food machine, capable of supporting large yields and continuous operation. Each component supports stability and maximizes yield. A well-balanced system is less prone to crashes and more resilient to change. Proper engineering prevents crashes and waste. Regular checks and smart design keep your system running smoothly. Automation frees your time and ensures reliability. With the right controls, you can scale up without constant supervision. The right setup transforms a passive container into a productive system. It's the difference between potential and performance. This is how you move from hobbyist to producer. With the right tools and knowledge, scaling up becomes achievable. Scale and engineering are the keys to abundance. With these core components, your reactor can reach its full potential. A scaled-up reactor is the heart of a closed-loop homestead. Its protein meal can replace commercial animal feed, slashing your biggest expense. Feed your chickens, get better eggs, and compost their manure for your garden, or feed fish in aquaponics. Fish waste fertilizes your vegetables. Integration multiplies your food security. The reactor's nutrient-rich water is liquid gold for your plants. Don't waste it. Use it to fertilize gardens or fruit trees. Every output becomes an input elsewhere, closing the loop. Your garden thrives, your animals thrive, and you reduce outside inputs. The sun powers the reactor powers your homestead. Waste becomes resource, and your property becomes a living machine. The protein reactor is the ever-beating heart, pumping life through your ecosystem. Traditional agriculture is unpredictable. Weather, pests, and soil can ruin your yield. A protein reactor changes everything. It's not gardening, it's manufacturing food in a controlled environment. You control temperature, light, nutrients, and flow. Output becomes predictable and mathematical. Once dialed in, you know exactly how much protein you'll produce each week. This reliability is the foundation of food security. You can plan, preserve, and support your animals with confidence. Poor soil or short seasons don't matter. A reactor works anywhere year-round. A small footprint can outproduce a field of soybeans. This technology frees you from geography and climate. Treat food as an engineering problem, and you gain control and abundance. Your homestead becomes a finely tuned machine for security and plenty. Self-reliance isn't nostalgia, it's an engineering challenge. The protein reactor is a symbol of this new mindset. You don't need a degree, just curiosity and determination. Backyard scientists and homesteaders are sharing knowledge every day. By building your own system, you join a movement for resilience. See your homestead as one integrated machine. Food, water, and energy are engineering puzzles you can solve. Start small, learn, then scale up. Don't be intimidated. Complex machines are just simple parts working together. Take action. Pick up tools, read, and build. Free yourself from fragile supply chains. The challenge is great, but the reward, true independence, is worth it. The adventure starts now.